Thank you, Anna, for the introduction. Today I will talk about soil management and agroforestry and benefits for climate mitigation, yields, and resilience. And I want to start this one coming from the agroecological view. When you look for agroecology and the publication on this topic and to make a cloud search on the most relevant words used here, you can see in the first one a lot of publication in Web of Science. The soil is in one of the biggest words, the keywords in agroecological publication, and also from the proceedings of the FAO International Symposium, the soil is here one of the biggest words. And the second one, it's not that dominant, but also in the last one, agroecological transformation for sustainable food systems, there is the soil here, not as big as before, but still a dominant word. And so soil is very important in agroecology, in agriculture, and soil health is so important for sustainable soil functioning. Just a short word, what is soil quality or what is soil health? There are some debates on these topics, and I want to give here one kind of definition. Soil quality is part of the environmental soil quality concept beside the water quality and the air quality. While here also soil health can be in the same line of plant health and finally the human health. And soil quality or soil health includes chemical and physical and biological approaches. And this is not only a static but also a dynamic concept. There are several indicators for soil health that we can have a look here. There are biological indicators. Earthworms is the most important, or is one of the very important indicators because they stand for the whole soil biota, but also the microbiological processes within the soil, like the end mineralization, the microbial biomass, and soil respiration. Further on, there are chemical and physical properties of the soil that can also be measured and are very important for the soil health and functioning, like nutrients, carbon and nitrogen, of course, but also macro and micronutrients, and the pH, and finally the total organic matter or the carbon content of the soil is one of the key indicators. Physical indicators include infiltration, aggregation, porosity, and various others soil structural properties. And when we go on with this, we see soil health is not including only the soil, the animals, the chemical and physical properties, but the productivity of the soil includes the interaction of humans in the soil, especially, of course, in agricultural terms. And so we have to include the management that is affecting the soil health. Here are some examples, like avoidance of pesticides to have a vivid and healthy soil, avoidance of contamination of the soil, for example, by microplastics, reducing plastic mulch, for example, antibiotics or polluted irrigation water, and on the other hand, improving soil biodiversity and beneficial microbial abundance. Avoidance of compaction can be one part to retain the soil physical properties, improvement of the physical structure, and somehow enhancing the input of carbon in the soil. In total, we have to look for different management approaches, from efficiency and substitution to a system redesign. Pierre-Marie already mentioned this term, the system redesign. Some action principles I will name here. It has to be somehow nature friendly, and this means beneficial for biodiversity, for the water bodies, for soil biota, and of course climate friendly with a total climate impact that should be positive or at least neutral or less contaminating. This includes on the one hand the sequestration from the air, but also reduced emissions of carbon dioxide, N2O, laughing gas, and methane, and of course no leakage to other systems and other production systems, for example. When we look on a topic here, I want to show that we have several different action spaces from agronomic field management. On the one hand, this is more a plot level action or measures. Then we come to a system redesign. And the biggest part we can do is a land use change. And all these have different impacts on the carbon sequestration, the total climate impact, long-term effects, of course. And to mention here only some examples, we have legumes included in the agronomic actions, grain or fodder legumes, organic mulch instead of plastic mulch, reduced tillage, crop residue management, or even improved crop rotation, including different higher variety of crops and crop families. Grazing management can be included, or optimized grassland management and cover crops or catch crops over the year. When we're coming further to system redesign, we have organic farming that was already mentioned before, and the integration of crop livestock systems within farms. The conversion of cropland to grassland is, of course, a high impact already on land use change almost, and agroforestry that I will come later on. And finally, a whole rewetting of peatland or organic soils might be the biggest measurement or the biggest measure on land use change. Not all of these measures are practical, not all of these can be applied all over the area, but it is an idea to go on. Improving the soil functioning will lead to a better sustainable production. Here we see some examples from a soil. On the left hand, a soil that is just used conventionally without any carbon inputs. And on the right side, a soil that is managed in an organic way with carbon input by compost. And on this soil, we already see just from the view, just from the first glance, that there is a different structure. There is a chemical, there's a carbon input to the soil, and so it's changing its chemical properties. So there's more nutrient retention by this compost input in the higher soil fertility. And the same soil was photographed sometimes later after a heavy rain event. On the left hand again, the conventional managed soil, and you see the water, the heavy rainfall has changed the surface. The water is just running up surfacely or staying, flooding the field, while on the right side, the compost and the organic management helped the physical structure of the soil, that the water can infiltrate, it is retained for later processes, and so the plants can stay and the production is going on. So this soil, by improving the management, has a higher resilience for heavy weather events, for example. I want to mention this citation of a publication. The soil is the base for building resilience of agricultural systems and maintaining yields. Healthy soil, maintaining functions for resilience building, and the yields might not be necessarily higher. I think we heard it already before, but we can also deal with the long-term stability and a sustainable future production of these soils. So now, how can we improve the soils? Really practical. How is, for example, the carbon as a key indicator coming to the soil? Of course, the best way is the direct CO2 uptake by the crops, by the plants via photosynthesis. That's how we get the carbon in the soil. Another way is, of course, the direct application of organic matter via slurry application or manure application. This is by fermentation or biogas. Here we have the direct input, but of course the roots have a high humus formation potential. better even than from crop residues. And we have the root exudates from living roots for the humus formation. Agroforestry, I mentioned it before, is a good way because the plants, the trees that are included in the system have a high durability, and that's why I really want to focus on agroforestry as an agricultural system redesign. I saw in the Mentimeter before, there are a lot of people already working on agroforestry, but maybe there are some people that are not so deep into this. We have agroforestry as the use of the same area, spatial or temporal synergies between components, for fostering ecosystem services and functioning. Here, one example for silvopastoral agroforestry systems. We have fruit trees, in this case, apple trees, with some sheep grazing between the trees. And on the other hand, silvoarable agroforestry systems, this is cropland, and you see the tree lines within the cropland. Agroforestry is a system redesigned from field level to landscape level. First, within the agroforestry system, you can have different tree lines to restructure your cropland. You can have simple tree lines with a single tree species, or even more diverse tree lines with different tree species with different purposes. The distance of the trees can be different, and also over time, when the system develops, when the trees grow, you can have a management that is reducing the trees or that is putting new trees inside. Pioneer trees like poplar or willow can be taken off earlier, and slow-growing trees remain on the field. And when we go from the field level to the landscape level, here are some examples for landscapes diversified by tree lines, first on an agricultural field, and then also within the agricultural croplands, you have between the fields the tree lines or shrub lines as hedges or productive agroforestry trees for timber or fruit.
Yeah. We're coming to slowly to if you can maybe. Yeah.
Okay. The agroforestry has, of course, very different properties like mitigation. We have the crops, we have the trees that can have above ground biomass production, but also the soil is improved by the tree roots. So above and below carbon stocks are increased, but also biodiversity through habitat and shelter and the landscape connectivity. Just an example from Germany, where we calculated the trees that are already used within agricultural landscapes, and this may improve drastically also the amount of carbon that is still and already stored in agricultural landscapes. And I want to skip this, just showing here the nice agroforestry system we have on our agricultural field. Yield is still a debate, how yield can be improved. That has to be further researched. There are some information already, but there has to be done even more. And but still we can see resilience can be improved, resilience of the system by a better microclimate, by improving water flows and water infiltration in the soil, reducing surface runoff and soil erosion. Just shortly to the system redesigned with a mixed crop livestock system. Pierre-Marie already mentioned this, integrating the livestock again in agricultural systems on a farm level or even on a territorial level with fodder manure cooperatives, and this to increase the efficiency between soil, plant, and animal systems, and hopefully to reduce yield gaps, especially in organic agriculture, by the closed circles. And so we come back to the approach of agroecology. to have a circular economy, not only including the agriculture and the livestock keeping, but the whole food system approach with the humans, with the consumption patterns and the consumer actions. And so thank you for your attention.